Good morning, good day, and good evening. I'm, as always, your host, Brody Robertson, and you have no idea what I have just witnessed for the past hour for this episode to get started. It has been an experience to get here, but now we're live, and I was surprised by how many stars the project had on GitHub because I've never run across it. So today we have two of the people involved in the Graphite project. How about you introduce yourself and just explain what the project is?
Yeah, so now that we do have our audio set up and our visuals set up after the hour of setup that you were witnessing for us, so Graphite. I'm the project founder. My name is Kevin, and basically we're building what I would like to be the graphics editor for 2D graphics that we can all, as an open source community, be proud of. And really, Parade is not just being an option, like a backup option, but more of the best option that can possibly exist in the entire industry. And that has been my goal for quite a long time. And since I started building it 4.5 years ago and getting this community together, it has really taken off, I would say, in terms of its actual technical engineering. And we continue to make progress towards being more and more of an actual application that people can regularly use and be happy about using. Because our goal really is to make something that has no compromises in terms of really anything, in terms of usability, in terms of its actual feature set, in terms of not only beating the open source competition, but also the commercial competition in time. And really the goal here is to build what can be kind of described as the superset or the generalization of all 2D graphics software that you can ever conceive of by building something that is unified in its grand vision. It's sort of talking about like the grand, the grand unified theory of physics or something where you have one theoretical model to put everything else inside of. We're building what is essentially, you could consider it like in the same way that a game engine allows you to build any game, we're building a graphics engine that allows you to then contain any 2D graphics workflow. So as the tools can allow you to draw vector graphics or raster graphics or page layout or animation or motion graphics or material design or really anything like that, or of course photo editing, image manipulation, it's like one engine with tools that are, artist friendly, designer friendly tools that manipulate the engine for you and essentially create your graphics in a way that can be described with a single unified data model. And you can mix together raster and vector and animation and combine those all into one program, while still staying within the ecosystem of what is basically one unified editor. And we've also started out, just for knowing what exists today, we've started out with building that engine, and that's a big part of what Dennis here has been very heavily involved with from a technical perspective. But we've also then had vector graphics. So you think, Inkscape or Adobe Illustrator, those programs being kind of the main focus for where we're beginning, because vector graphics is kind of the primitive from which you build up everything else. It is kind of the most fundamental form. You're describing things with curves and with lines. And from that, you can then build up and say, oh, well, if I have this sequence of lines that can describe a brush stroke, and then a brush stroke can be raster, and then you can render raster, and you can use that for masking, and you can use that for controlling how you edit images. So we're starting out with the basics, and it also allows us to continue to make the technology more and more mature with the overall engine, and then we'll be moving more towards raster next year, and many things beyond that. Of course, animation, we have that now as well, but that's going to continue to be more and more supported, so you can mix together design, image editing, that sort of thing, with throw in some animation while you're at it. It's all pretty unified.
If anyone couldn't tell, Kevon has been the one who's been doing the videos on the updates. He's very good at talking on camera, it seems. Dennis, introduce yourself.
Continuing the introduction. I'm Dennis. I study computer science in Germany, and we're also currently recording here in Germany. And if you couldn't tell, Kevin is the one with the vision, and I'm here to make that actually possible, to make it like feasible, to tractable, to compute this. And there's a quote from a German politician. Those who have vision should see a doctor, and I'm here to actually make the visions reality.
After all, his screen name is True Doctor, so he is, of course, the true doctor.
Oh, was that the end of your intro?
Oh, well, I thought I might keep it short. I have a peppermint tea here, and on one of my devices I use Arch, by the way, and the other one is currently in NixOS, and yeah. Oh,
Okay.
and one of the things that always annoyed me, like I used to love photo editing and was using Adobe Photoshop, but then I moved to Linux and it just wasn't as, like, it didn't bring me joy. It wasn't as nice. So I've been longing for some alternative to get back into like creating, and that is the vision and the reason why I joined the Graphite project.
I guess similarly, to add on to my background a little bit, since I glossed over that part, since probably like elementary school, back when my computer lab in elementary school, we had 4 computers off in some room, had Flash on it, and as well as some really old version of Photoshop, and going from like turning my classmates' hair purple and that kind of like basic stuff, up to doing some within a few years doing some freelance design work for like some book covers, and just really teaching myself computing in general through the means of creative software. That has been sort of my upbringing, and how I am a programmer and a product designer and a graphic designer nowadays. But that has been sort of my upbringing, making Flash animations, and then eventually that moved into also little Flash games, but then that moved into some Unity development, some web development, and that's kind of just been my background. I've generally been motivated by kind of frustration with other software, seeing whatever it might have been. Like back in the day, I was learning to do app development through frustration with iTunes being a really terrible way of playing music, your local music collection. And I never ended up completing that project because I restarted it like 5 times as I learned more and more and got better ideas for the technology stack. But yeah, building basically a better music player app that has consumed a few years of my life as I kept restarting the project and improving the design. But for me, product design has always been sort of an intuition. It's always just kind of clicked for me. It's like I see a bad design. It's like it's so obvious to me in my mind about how this could be improved with things that seem like they should have been obvious design choices, but I guess they never occurred to the designers, or they had some sort of budget or time or other sorts of technical limitations, and they were not able to achieve those better approaches that seemed obvious to me. But that's basically through frustration with other software that has been my motivation to build and teach myself all of the different skills for both engineering and designing better software. That's what drives me.
Okay. So where did the project start? So you said it's been about 4.5 years, yes?
That's the time that we began developing it. I have had the ideas rolling through my head, because also I forgot to mention I've been using Blender since 2.49, quite a long time ago, right around the era before the open movie project Sintel came out. So yeah, quite a while for, I guess, probably many people who have joined Blender in its more mature days, but it certainly existed plenty before I started using it as well. But I was using it in like middle school to do my middle school film project. We had to do like some sort of film project, and I animated everything. But yeah, so Blender has always been a really big inspiration to me. Even back then, when certainly its quality wasn't nearly as good as it is today, now it is truly industry leading. But I always thought that, despite the difficulties of its UI, I never thought it was really that bad, simply because 3D software is inherently complicated.
Right.
Whereas 2D graphic software really doesn't have to be inherently complicated. There are many ways of simplifying it and keeping it reasonably simple. And I've then, grown up using Photoshop and grown up using Illustrator. Well, Photoshop's a better example of a better user experience. Illustrator doesn't quite manage that same bar. But Photoshop, I would always describe as being pretty intuitive. Like, there are technical things you have to learn, and you have to, you have to find a solution to a problem that you have using a certain set of operations that you have to learn over time. But once you do that, you can really do anything. And they're not inherently that complicated. They're not buried behind too much UI. So
Any technical field is inherently going to be technical and complicated, but it presents the information in a way that the application doesn't get in the way. Yeah,
exactly. So the goal really is to have, an application that can stay out of your way, but also be enabling whatever you might need to get done. So that's sort of been my design philosophy. And I've always, really appreciated that Photoshop has done a really good job with that. I have quite a lot of respect for the software, because it is, in my book, quite awesome software, actually. It has limitations, and those are some of the limitations that have inspired my design process throughout the years. So we were talking about the timeline for 4.5 years ago. We started coding this, but since I started Blender, I don't know, 15-ish years ago, whenever 2.49 was, since then, I've been sort of like, what if there was an equivalent to Photoshop that was also free and open source like Blender was? And, didn't think too much of it in the days, but then over time, ideas kind of percolating in my head and figuring out what that could be. Eventually, I started realizing, okay, the main limitation with Photoshop is that even though it has support for a lot of non-destructive operations, and we'll talk a bit more about non-destructive for anyone who's not familiar with what that means, but non-destructive operations are really like, that is the pinnacle of what graphic design, any kind of creative workflow should be about, is supporting non-destructive editing as much as possible. And Photoshop goes a pretty good way towards that, but it has limitations. You, at some point, have to start making destructive operations, which means you have to bake in your decisions and you can't go back and make changes after that point. And my entire sort of philosophy was, what if it was possible to use nodes that's really popular in 3D software with shader editing and Substance Designer style material editing. And, I didn't know about it at the time, but Houdini is a really good example of another professional application that's frequently used for VFX in Hollywood and for game development, creating like simulations and creating, procedural town or city generation, or, many combinations of assets, creating like a process, creating a workflow, a procedure, like an algorithm to generate whatever you might think of, whether that's a building generator that can generate any building based on any floor plan. You're basically taking data as input and producing some sort of final output based upon some final asset as your output. So the idea I thought of is like, it seemed really obvious to me. Can we take the ideas from 3D, which is node-based generation that allows you to make non-destructive as the core idea of the workflow, non-destructive editing. And can we take that and put it into the 2D context? And no one's done that. I have no idea why. I mean, I guess the answer is that we're finding out here. We knew it would be hard, but we're finding out that it is even harder than we might have even thought it would be, which we thought it would be quite hard. But it is ultimately, like, the goal here is to build this non-destructive procedural graphics engine using a node-based system to encode your artwork while, and this is the really, really important part of our core design philosophy here, making it wrapped up inside of an editor that doesn't feel like, or even doesn't expose the fact that you're using nodes at all, unless you choose to opt into that complexity. And it's not a opt-in like you have to permanently flip a switch and now you're stuck with that complexity. It's you're using layers like you're used to in a regular graphics editing software. But at any moment, if you feel like it, you can go just look at the node graph, just open the button that brings you to the node graph, and you can start modifying nodes, and then you can just close it and never look at them again. And it doesn't opt you out of layers or anything. So the idea is that you're not stuck with it. If you choose to opt in, which is the case for some software, you have to like permanently say, I want to go out of the basic workflow and move into the node-based workflow. And you never get to go back at that point. The other part is that for users who want to work with a traditional editing experience, they never have to think about them. It completely, the tooling abstracts over everything that you'd actually interact with. The nodes are done in the backend. Visible if you choose to open it, but otherwise never a thing you have to concern yourself with if you're a user who is not familiar with that complexity.
And we should probably at some point also address your question. So you were asking about the development timeline. So 4.5 years ago, was that when we started the...
Yeah, February of the Rust Game Dev Meetup.
Yeah.
In 2021, I believe.
So basically, the origin story is Kevin made a design mockup.
And that was like started a couple of years before, actually. So I got to reuse some college credits. Basically, I was in my last year or so of graduation and got to reuse some get some credits basically to get out of college in time, while at the same time putting time, like hundreds of hours, into doing the design mockup and moving that significantly forward to the point where it was something we could actually use as sort of a guiding light towards building the system.
Exactly. And there is the Rust Game Dev Meetup, which was just streamed on Twitch. And Kevin went on there and presented his vision for Graphite. We didn't really have much functional code ready then, but I happened to watch that live stream and got engaged with the project, joined the Discord. And yeah, since then I've never stopped, and we started laying the foundation, building the editor, and it's been going great since then.
Yeah. a huge amount of technology and a huge amount of evolution of basically how do you take shortcuts in some areas that allow you to progress in other areas, because you can't do everything at once, or it's like painting a painting. You can't paint the tiny corner of the painting and then move on to the next little corner next to that. And then eventually, after 20 years, you have a completely highly detailed painting finished. You have to, take shortcuts, draw sketches, and then start filling in whole areas of basic paint. And then eventually you can start adding more and more detail, but you can't just start with everything at once. So software development really is about where can you strategically take shortcuts. And strategy really is a really, really important part, because there are many projects that fail based upon not having the right strategy or the right leadership to get that kind of thing figured out in a way that's able to execute in a way that's simultaneously useful to users in the short term and in the medium term and in the long term, but also able to produce something that ends up having not painted itself into a corner and get stuck with permanent decisions. And one of the really, really important philosophies for me is that we don't want to ever permanently paint ourselves into the corner of being unable to make a certain decision later on. The lofty goal, and I realize it's very lofty, is that we never want to say no to a feature. And I don't mean feature creep. There's a very big difference between feature creep, which is bad, and making the ambition of having something generalized enough to be the best possible editor based on anyone's reasonable definition of what could be considered the best editor. Because if it can be generalized enough in its overall vision to support every use case, because it is ultimately a programmatic engine, in the same way a game engine, again, I mentioned earlier, a game engine can be considered generalized enough to support any game engine, or at least a sufficiently powerful one. Like game makers, I think, focus more on 2D, so you probably wouldn't be able to support a 3D game. But we want to make a generalized enough engine, like, for example, Unity, that supports 2D and 3D. I'm not saying that Graphite is intending to support 3D in that maybe some little ways, but it's not ever intended to be like truly a competitor to like Blender, for example, because Blender does an amazing job at what it already does.
There might be some value in importing a model and then being able to rotate that, for example.
Exactly. Like there are cases where you might want to model some sort of sculpture, let's say, for example, in Blender, and then import it in and turn it into vector graphics in some way where you're having like these different like petals or flaily things that could look nice in a 2D context, but you ultimately have to design it in 3D. That's an example of where we would probably have some sort of model import or something like that. But yeah, that's down the road.
And basically, if there's one thing that Graphite does not have,
this is the quote.
Yeah, if there's one thing that Graphite does not have, it is a lack of ambition.
That has been the much pinned quote that frequently comes back, because essentially, as I was saying, the vision is to support all possible visions within overall graphics editing or 2D graphics editing. But yeah, don't make any technical decisions that preclude the ability to eventually move towards that grand unified goal of everything, of supporting everything.
Right. Do you have more questions?
Yes.
Otherwise, we're just gonna keep on yapping. And
that's totally
never
fine. I love the episodes where I don't have to say a single word and the guests just yap the entire time. Okay, so when I was looking around at Graphite and sort of seeing how people feel about it and what they've said about it, I'll often see discussions saying, "Oh, Graphite is kind of like it. It's in this same class, or it's going to be. Obviously, it's still an alpha and long way away from being fully realized, but it's in that same class of things like OBS, which is an industry standard now for doing streaming and recording, alongside Godot for doing game development, Blender for doing 3D. This is the 2D graphics side. And all of this sounds great in theory, but right now, where is it? Like, how far along the vision? How usable is the software? Is it something that you could reasonably actually use in a workflow, or is it still a long way away from that point?
I would say, yeah, if we're talking about sort of the initial thing being by comparison to Inkscape, where it's a vector graphics editor, because that has been our primary focus thus far, we're in a state where I would say for a beginner who is not familiar, they might be familiar with Illustrator as like understanding vector graphics, but they have not specifically used Inkscape to work through its quirks. It is probably this is based on the feedback we've had from many users who have reported. So basically we're in a state where by comparison to basically vector graphics editing software, because that is where we are at this moment with our strategy, we have to focus on some things first. By comparison, Inkscape is kind of the most similar program to what the feature set of Graphite is today, because we have to take that roadmap and build out the roadmap over time towards the eventual roadmap of there's no end to anything that might be a limitation, because we'll have something unified enough to support all use cases. But now we have to support vector graphics editing. And of course, many of those use cases, by the way, will be plugins, or they'll be kind of user authored things, but we're building an engine powerful enough to support everything within the use cases of what someone might want to author themselves through the plugin system. But yeah, so Inkscape is, I guess, the most fair comparison at the moment. And the feedback we've gotten from many users have been using Graphite is that if they're, especially if they're already familiar with Illustrator or other vector graphics editing software, but not specifically familiar with the UI and the idiosyncrasies of the UI of Inkscape, they found that Graphite is more intuitive, but we of course do still have some limitations, but also some advantages. So the node system allows kind of like an escape hatch, where you do have to get technical these days to use it as an escape hatch to re-implement some features that we don't have that Inkscape, because it's been around for, 25 years or something, maybe even 30 years. They're a really robust and just many features over the years they've been able to build that makes it up to industry standards. So yeah, one example would be text on path. So you draw a path and then you can draw text that kind of follows along that path. And we just haven't gotten around to building it. Actually, it's the kind of thing, if anyone wants to build it right now, there's nothing blocking it. You can join our community and get involved in building that as a proper user-facing tool. But we do have the node system that allows you to recreate those. So you could make it work on your own. And there's dozens of examples of we don't have like a system of using patterns to fill objects, but you can make the pattern yourself and then clip the pattern on top of another object. So different cases where we don't have the direct feature, but we have enough tools to go recreate it yourself. But for regular artists, we don't expect you to have to know those technical details. But on the other hand, we do present a UI that is generally more familiar and generally like the kind of thing that, as long as you're moderately familiar with creative software in general, we have sort of like a regular unified layout that you'd expect from any professional graphics editing software. And most of our users have found that that is a lot easier and more approachable than Inkscape. I've personally not managed to ever open Inkscape and do much more than draw a rectangle, because it's just, I found its UI to be a little bit too full of quirks. I just can't quite get my head around it. I'm sure if I watched some tutorials and really, spent the time to get familiar with its quirks, I could work around that and get familiar and useful and used to it. But I want software to be approachable to a beginner. And I have really high standards for software design. So as a result, I've not really found that Inkscape meets my needs in those regards.
And I guess more on the status of how mature is it currently. So we are still in alpha. And I guess one of the biggest drawbacks is that and one of the things we want to work on next is that we build a stable document format. So currently, we can't guarantee that documents will work in the next version of Graphite. The skills you learn while using the app still transfer, but the documents might need some manual tweaking to get working in newer versions. And that is something we will definitely need to fix before we go into beta.
And the timeline for that we're expecting is around the end of the year or early next year for that. That is basically one of our imminent focus areas.
Yeah, that would be one of those things where I would need that to be in place to legitimately use it, because I've thought about trying out doing like my thumbnails in it just to see how that would go. But I have like a layout document that I've got made, and I fill in things with what I need, and having to make sure that always is working. For all the problems that GIMP might have, it's a very stable format. I can take a document from 20 years ago, it's still going to open just fine.
But one thing that could work well at some point is that we have, one of the nice ways about of using this node graph is that we basically run the program. So you edit your image, you can edit your thumbnail in Graphite, and then expose these inputs. For example, the title would be an input. And we do also have a CLI application. And what you could feasibly do is that you feed in these CLI, like title, for example, as a CLI argument, and will just render the document for you. And
Okay.
The node graph-based approach lends itself naturally to this sort of batch processing or CLI argument filling. And it's actually kind of nice because in other software, if you want to do things like batch processing, so you have a black spot on your sensor and you need to correct that in 500 images, you do have this extra automation built on top of the editor.
It almost ends up usually being like a macro system built as sort of like a bolt-on feature in many other graphics editing programs, and it's never really like part of the core architecture.
And what we do
an
in
example
Graphite
with
is that
GIMP, for example, is you can like there's like a Python interface for it where you can just say do this action, do this action, do this action, and it works. It's a perfectly fine system, but it is still effectively just a macro system.
Yeah, exactly.
And what we do in Graphite is that we, like, as you're using the tools and modifying the document, your document is sort of like a program. And we build, like, the node graph is a visual representation of this document program. And the program says, like, given these inputs, process them in such a manner that we get this output result. And what you can do is that if you do this for one image, like you do the operation for one image, we can then take this as a program. We can basically just copy the node that applies this correction and apply it, like you can sort of think of it like having a read every image and folder node. Then we map it by applying the operation that we did manually in the editor. And then we save it back to the disk. So we don't need to build the batch processing because it's just an emergent property of our system.
We're essentially creating what I think could be described as the first programmatic 2D graphics editor, where everything else has been built with a specific set of features in mind. It's a graphics editor that has been built to edit raster images. That's what an example of what Photoshop is or what GIMP is. Whereas what we're building is a programmatic graphics editor, where the idea is it is very literally an IDE for the code of the language that is the description of your graphics. Kind of like how you would write an ImageMagick command, or you would write almost like an OpenCV command or something to make processing to images happen. Except you do that in a purely visual way. You don't use code, but you actually edit with tools that allow you to draw a rectangle and use the pen tool to move around a shape, and then use the brush tool to draw, to draw some brushwork. Except that is actually coding on your behalf behind the scenes in a way that allows you to think like an artist, think like a designer, but end up with code being produced on your behalf. And that code is not visual. It's not textual code. It is the nodes that get created on your behalf, where nodes are basically functions that get certain parameters. So, for example, the node that generates a brush will have the mouse positions of where you moved your mouse, or the pen positions of where you moved your pen, and also how much pressure and angle was involved in the pen pressure. And that can then render into a brush. And the coolest part here is that we're not baking in a specific resolution. We'll get to this system a little bit in a bit more time, but basically the idea is that we can re-render your artwork at a different resolution. And re-export at any resolution you care about at the time that you're exporting a file, or even that you simply zoom in. So your brush stroke you draw by recording your mouse movements, and then you zoom in more, and now you don't have a pixelated brush because we re-rendered that brush again. So the idea is you're creating a program, and there's no limitations such as what is resolution. Resolution is basically a unit system that allows you to easily have a document resolution, but that document resolution is not going to result in pixelation as you would expect it would in Photoshop or in GIMP.
Right. So normally what you go on.
Yep. Yeah. The
latency.
It's gone.
You guys don't have latency between you two. This is weird for me. Usually when I have guests, you guys are the ones talking over each other.
Please go on.
I was going to say, normally when we're talking about 2D graphics software, there is a clear distinction between vector graphics and rasterized graphics, where, you can make artwork in a vector software like Inkscape, but this is a different thing. Your workflow is all vector, and then you rasterize it when you're doing your final export. Or then you look at something like GIMP or Photoshop, it's entirely done through rasterized graphics. But here you're saying, if I understand correctly, you could do a brush stroke and then say, I don't like exactly how this is done, and I want to, add in a curve to this, and you don't have to redraw that. You could go into the node system and then modify just that at the code level if you're someone who feels like going that technical.
Or you could like resculpt the brush, for example, as well. You could use like a sculpt tool to just
Or
push around the brush.
I assume you could change the brush to another one.
Exactly. Yeah. Change the radius, change it to like a watercolor brush instead of a acrylic brush or anything like that after the fact. That's what it means to be fully non-destructive. Is you're encoding the decisions that went into the creative process. You're not baking in the decisions at the moment that you drew them into the pixels of the artwork, because there are no pixels. There's only a program.
Yeah.
With this idea fully realized, I'm not artistic enough to understand what it could be used for, but at a surface level, I think, you could draw an image and then completely change the style you have it in without redrawing that image. And I'm sure people who are artistic and have like a technical background can think of far more interesting things to use it for, but that in and of itself is already like really cool.
Yeah, and also like if you generally with most other graphic software, you pick a document resolution up front. So the first choice you have to do is to pick the resolution. Maybe you're on constrained hardware, you only have a laptop available, maybe a school laptop, and so you choose a smaller resolution to work on your image. And then the image becomes really cool and you want to export it and print it on a billboard. And that just doesn't work because now you don't have enough pixels. And what we do in Graphite is basically you only pay for what you use. So we can render the image always at your current viewport resolution. So if you have a bigger, we record the movements and we only render what's currently visible. So you can always export it at a high resolution, and that's just an export that's going to take longer, but it doesn't impede your workflow. That's one of the core visions of this adaptive resolution system.
Or the other funny thing you could do is you could go hide Easter eggs inside of a piece of artwork by zooming into like 1,000,000% and go hiding a little doodle or something somewhere you'd never expect it.
Yeah, if you know these, sometimes on YouTube you can find these infinite zooms into artworks. That is something you could also do.
Yeah. You start out like 1,000,000% zoom and you just start drawing, and then you just start zooming out a little bit as you go and just continue to draw more, because the brush system, again, it's only recording your mouse movements and it's rendering it only when you're viewing it. Yeah.
I'd cut you off before. Was there something, do you still remember what you were going to say before, or did you lose it?
I mean, I guess we can. So what I was sort of starting to explain is how this works. Like, if I, for example, draw a box, this is going to be a bit more technical, but
be as technical as you want to.
If I draw a box, that creates a node, and that node is just a node that returns a rectangle. We then feed that node into another node, which gives the rectangle a stroke, so like an outline. We then feed it into another node, which gives the rectangle a color.
A fill color.
Yeah, a fill color. And that's how we can, you did your operation, you drew a rectangle, but now we translate it into this set of operations. And if you want to change the color, you still have the same geometry. You can reuse the geometry from the rectangle node and just go to the fill node and change the fill color. And that's sort of the mental model we work with in Graphite.
Yeah, and of course the important part is that the tools did that for you. You could go to the node graph, add your own rectangle node, then add your own stroke node and your own fill node, and set up the color you want for the fill and the stroke, set up the width and height for the rectangle, but the tools can just do that for you. And it's much, much faster to just draw it like you would in any other graphics editing program. You just draw a rectangle. It's truly that simple. And the system adds that node, that set of nodes for you, and it becomes a layer. The important part is we still have the layer system as well. So the nodes feed into a layer. Essentially, you could think of layers existing in other graphics editing software. They just internally represent in whatever internal data structures that the software developers created for their use case of, for example, vector graphics or raster graphics. In those cases, they've built some internal data structure, but you don't have any control of what that is. And it's just storing whatever you drew. But in our case, the layers are more like outputs for the data that the node graph generates that either you don't see or you see, depending upon whether you open or don't open the node graph. So they're more of outputs for that data that gets generated along the way, and you have therefore more control over that. But at the same time, it could be exactly equivalent to other software if you choose to never open the node graph.
And I think one of the sort of natural transitions we could do here is that we did already talk a bit about the sort of adaptive resolution idea. So we don't pick up resolution up front, but rather we record like basically all the user inputs, and we can render it at a different resolution. What we can also do is that and I did also mention this, we only render what's currently visible. So previously I described that basically the entire thing, like the entire document, becomes a function with inputs and outputs. So it's a program that takes some input and returns an output. One of those inputs is the area you're currently looking at and the resolution. So the current viewport position is an input to the program. And in that sense, Graphite becomes basically more like a game engine, because on each frame we have to render the artwork with the current camera position. You could sort of think about realizing this as a sort of 3D map. If you place your image in 3D space, we have a rectangle in 3D space, and you can then move your camera. So in a sense, we're much more similar to how a game engine would work. And that does naturally lead us to one of the biggest concerns we always have to worry about, which is how do we make all of this fast? And
Right. Because it's nice to be able to do this, but if you need a 5090 for it, it's not exactly...
Yeah.
It's cool. Like, it's technically cool, but it's not viable.
And we want to work on low-end like Chromebooks and things in classrooms. Because in fact, the classroom market, even today, actually, we've been looking through our analytics and seeing about, I think, around 20% of our visitors are coming from classrooms during the weekdays. So it really is actually an important market, and that's only going to grow over time as the skills that are taught in classrooms need to be more and more technical and more focused on creativity as opposed to just the traditional subjects. So I expect that to grow, and we want to make sure that we're as accessible as possible to all users, whether that's on Chromebooks or whether that's on a 5090 with a nice beefy gaming computer. We want to support everything in that entire hardware range between those. Yeah. And of course, you mentioned like basically a server GPU there as well.
Yeah.
We also want it to be able to, if you are an actual film studio, which normally has to produce graphics, like 3D graphics that usually go off to a render farm. We even want to support a case where, because we're basically building this generalized graphics engine in the same way you think of it as a game engine, we want to be able to generate something that is so computationally expensive if you're crazy with it and you're generating, you're importing like a terabyte of data that's used to do data visualization or something. We want to support a case where we literally are the software running in a render farm to render frames offline in some case where it takes 15 minutes to render every frame like you would for a 3D movie or something.
Right.
So we really want to support the entire gamut between actual render farm hardware down to Chromebooks.
And actually, talking about where you use Graphite, currently we have a web app. And we are also working on a desktop release that's going to come soon, and we'll maybe talk about that a bit later.
Yeah.
But first, the desktop, the web app. It does use JavaScript. We do use Svelte for the front end, but all of the logic is written in WebAssembly. It's written in Rust and compiled to WebAssembly. So our main editor has always, from the ground up, built with having a native desktop app in mind, and we use Rust for basically everything that matters, and only use the web for the UI because the web is just good at UI. And that's sort of the tech stack we're building towards. And yes, I needed to mention that it's written in Rust because that we are obliged by the Rust Foundation to mention this.
We're not actually obliged by the Rust Foundation to mention this.
It's also important that, because I know people are going to see it has a web app and immediately write it off. It also is important to mention that is what was done first. That is not the final goal of the project.
Yeah.
And it's not...
I talked about strategy earlier, and it's really about the strategy of finding what battles to fight at what time in the roadmap, while eventually knowing that you will win every single battle. And we even have a roadmap towards eventually getting rid of any web technology at all further down the road. by having our own render engine be so sophisticated that it can render our own UI in itself, where you can update the appearance of a button in your own editor while the buttons all throughout the rest of your editor update live while you're editing that one button. So
yes, that's the other thing. The intention is also not to be, I know people are going to immediately think because it is on the web right now, it's going to be an Electron application.
Yeah, no Electron.
No Electron.
To be clear, it is built as a native app using a native language that gets compiled into a format that simply is capable of being hosted within a browser. But it is a native app running in a browser, which technically, based on how you want to define things, you could call it a web app. But I think of a web app as more of something that's written in JavaScript. And aside from a tiny bit of UI code, it's like 5% of our code base that just accounts for like, these are the buttons you can press. These are the drop-down menus you can select from. Those are just really lightweight things. We've intentionally built everything to be as lightweight as possible. We're not really using any libraries aside from like our UI framework of Svelte, because we know that libraries typically add like 10 times as many elements to the HTML DOM compared to what you need. And we don't want that. So I want to build my UI that I designed as part of the UI mockup in as few HTML elements as possible, using as few lines of JavaScript as possible or TypeScript, just to be that like 5% of our code base that involves just the things you see, the things you click on, the things you interact with surrounding your viewport, knowing that you spend most of your time in the viewport, drawing and painting, not actually touching buttons and things, because those ultimately are not latency sensitive. They are like the UI, if it's written well, if it's not written with a thousands and thousands and thousands and thousands, maybe hundreds of thousands of lines of JavaScript, like you might expect Slack or Google Docs or Teams or whatever desktop applications that tend to be, or Discord, they tend to be rather bloated and have a high latency, and that's just because they're running through a tremendous amount of JavaScript. Whereas in our case, we are running through maybe like at most 100 lines of JavaScript when you click on a button or something, and that's just instant, like nanoseconds, not milliseconds. And then it's running native code after that point. In this case, in WebAssembly. But as soon as we have that desktop app, it's running directly Rust code, so compiled code. And the reason we say Rust is because it's important to know it's not JavaScript. It's Rust, which you can basically think of as equivalent to C++. It's just we're starting a brand new project, and Rust is the more modern language to use instead of a 25-year-old C++. So that's why we chose that. It's mostly for maintenance reasons, that we can make really large-scale applications and have the compiler make sure that it knows that we are not making mistakes that C++ would have a harder time catching.
I was about to ask you why the choice of Rust, but you pretty much already answered it there.
It really is just about maintaining a very large-scale code base. It's easiest to do that in a modern day in Rust. We care about high-quality code because this is going to live for decades. And as a result, it's going to do a better job than C++ will at making our lives easier.
And another reason is that we need basically the full range. We need both low-level implementation, and we need to be able to optimize things because it's going to be very performance sensitive. And we also want to use one language and have the full range to application scale and have all the abstractions we would want from a language.
It's kind of
the editor UI.
It's kind of the first programming language that allows you to have low-level speed, like basically C++ style low-level systems programming with high-level conveniences, which is not something that C or C++ can deliver on. They don't really provide those high-level conveniences, where we get to mostly feel like we're writing in something like Python or JavaScript or Java, where it's like a high level, or C#, where it's high-level conveniences, and we get to therefore maintain a really large-scale code base and not have the burden of worrying about when things just totally collapse because the Jenga tower you've been building for the past 15 years has just collapsed from beneath you, as it would in C or C++, where the moment you got to go refactor some big system, it just becomes this nightmare of finding bugs for months and months and months, and users hitting crashes because you changed the foundation out from underneath you.
And that's also like if we get new contributors, and some people just add one feature that they like that was annoying them, and they make a pre-alpha it. It's easier for us to have confidence that their implementation won't break other things. If we know that it's compiled, we know it doesn't introduce any undefined behavior, that's always like a good start. And then we just need to check if the logic actually works.
Also, the one last thing that can't be under-accounted for is that Rust as a language, because it's newer and it's a little more like fancy and stuff, it ultimately attracts really smart people. So Dennis is like actually a genius, and we would not have found, starting the project, we would not have encountered Dennis if it were not chosen. If we were just using C++ or something that has, heritage as a multi-decade language that thousands or millions of people know. It doesn't have the community built around sort of a niche of really, really smart people who have self-selected themselves into a group of the people that we can ultimately recruit as open source contributors.
I don't.
Oh, speaking of open source contributors, I want to also remind people, because oftentimes when they see our application and they're like, wow, this looks super professional, they write off in their head that this is actually just an open source project.
Yeah.
I want to take this moment to emphasize that we are an open source project, not a corporation. We are not backed by anything except donations from the community.
Apache 2.0, is that the entire project? That's what it says on GitHub.
That is our license, yes.
Okay.
Yeah. We want to make it as permissive as possible because we know that we want to be used by corporations. We want to be an ecosystem standard, essentially. So we don't want to limit how anyone can use it, where, if we were using a copyleft license like GPL, it would basically be harder to be adopted. And we actually want to be adopted as much as possible by as many users, including corporations, as possible, so that we can basically become the standard of the industry.
Is there a reason why that specific one as opposed to like a MIT or a BSD3 clause, something
They're
like that?
pretty much exactly equivalent.
Sure. Okay.
Mm-hmm.
It's at the start of the alphabet. There you go. There's
Sure.
your reason.
Yeah. Yeah.
No, I wasn't sure if you had like any actual reason why it was specifically that one as opposed to any of the other permissive licenses.
Yeah, I guess if I remembered now, I probably would have made it exactly a dual licensed MIT/Apache, but I just picked Apache because no reason at all. They're pretty much exactly equivalent.
And I think they both allow relicensing.
Yeah, exactly.
Yes.
Yeah. There's no actual distinctions between the two except for like specific legal terms or something that aren't actually relevant.
Yeah, I think there's slight differences in attribution. That's pretty much it. But the actual permissiveness of the license really doesn't change.
Yeah, like someone could relicense the Apache code as MIT code, I believe. So
yeah,
anyone else could just take it and then do that with it. Yeah. That said, of course, with our license, our goal really is to make this the standard project. We want to be the clear organization running the project. We don't want to go have 500 forks doing their own little creative, cute little thing. We want to make the software so flexible and extensible through our programmatic engine, essentially, that you build all of your use cases, because we support every possible use case by making the generalization of everything in one program. So that way we really don't want to have a bunch of forks all trying to compete with us in some way of like splitting the ecosystem apart, because we've seen other open source projects where they don't have clear leadership and clear organizational standards, and they end up having tons and tons of forks that ultimately kind of just have everyone not moving in the same direction. They have everyone moving in like opposite or adjacent or perpendicular directions.
WordPress drama.
Yeah,
sure.
So we ultimately want to be the one organization, and we intend to continue doing a really good job at running the organization. But we basically would like people to continue to contribute to the project and help us move forward. But that said, we do have also a very permissive license. So if we ever, for some reason, decide to drop the ball on that, then anyone can go take up exactly where we left off and continue on.
Yeah, I think one thing we didn't get to, and you started, if you want to contribute, if you're interested in graphics programming and Linux and want to use, or maybe you want to try out the desktop app, go to graphite.rs, and there's a button to launch the app or a getting started guide, and join the Discord.
Available today.
I was going to ask, I don't think you said it during your introduction. You might have, and I might have forgot. What is your actual educational background, Dennis?
I studied computer science. Well, I'm currently doing my master's in computer science at KIT in Karlsruhe.
Okay.
So Germany.
Yeah, and in my case, I went to Cal Poly San Luis Obispo, and I did my undergrad in computer science, and then also got a master's in also computer science, and then graduated a few years ago. The idea now is like when you're early in your career, that's the right time to take a risk. I'm probably giving away like millions of dollars in terms of opportunity costs that I could be making right now in Silicon Valley, which is where I grew up and where I live. But I really do care about the open source community, and I want this to be my career. I would not be happy being some individual contributor at some other software company. I want this to be the thing I do for my entire career. So I'm kind of putting a lot of risk personally towards making this happen, knowing that in the long term, it's going to pay off for me making a career I'm really happy with. And hopefully that also means that we can get to a point where it's a sustainable like venture. Once we eventually have some business models that are completely still in the spirit of open source, we'll be able to, for example, allow you to host your documents on the cloud only if you want to, because you want to, for example, switch between an iPad to do drawing and your desktop computer if you want to, mix between painting and not. But that's not a thing we shove in your face. That is a thing that you could choose, that if you read about the fact that we support an account system that you could upload. We don't even have any servers at the moment, but in the future, once we eventually have that, the cloud syncing between devices is a way that we could have some sort of revenue. And once we expect to have millions of users, that becomes enough to have hopefully a sustainable business. I also mentioned the asset, or I did not mention the
I
asset
don't think you
store
mentioned
yet.
that. No.
But I mentioned plugins. Like, if the goal is to be as extensible as possible, we're basically making a package manager like npm or pip or crates.io.
Well, I
the
guess a
package
direct
manager
comparison,
for the
since you've talked about
packages
game
of
engines
your-
before, Unity's asset
or
store.
the Unity asset store. Exactly. Yeah. And the idea is, really you're making something so extensible that people make all of these reusable things. And there's a big market, I'm sure, eventually for, like, even in the Blender community, there are several different asset stores that are commonly used. They're not officially run by Blender. And I do think that's a missed opportunity by them to not capitalize on being the official source of people selling assets to one another. And of course, giving them away for free. I would expect most people to be giving away their assets for free. But if we do payment processing, then I think it's fair to take a profit cut from that and put that back towards the project, hiring people. Our goals are just so ambitious that we need to have a giant team someday.
Sure.
Yeah. And it would be good to really have a business model that is sustainable instead of relying long-term only on donations, which is a situation that Blender has found themselves in a favorable position for, because they do have large corporate backing, because they ultimately are kind of a standard. They're used as a benchmark by NVIDIA and AMD and Apple for all their hardware, and Intel. So those companies back it because they want to see Blender be like the best on their own hardware. But that's a position which maybe we can someday move ourselves towards, but I don't think that's something we can rely on, and that's going to take a very long time to reach that point. I also mentioned, like, we would act as a render server for render farms. That might be something where if we need to have like an orchestration system across 1,000 different machines, we could maybe, because it's such a niche case that's only used by big companies, we could maybe charge for like that specific kind of orchestration system where no users need that. But we really are focused on keeping it anything monetization wise not shoved in front of your face ever, and also not in a way that detracts from the spirit of open source, because this is really what we're trying to build while still being able to not only rely on donations longer term. But at the moment, we rely entirely on donations because all of our eventual business model options can basically be things that we can't do in the next few years because they just require so much technological build out and also a sizable number of users before those become viable at all. Like, the asset store is probably the soonest one we could expect, but we still have to build a good amount of technology, and we have to actually start building a backend with hosting and infrastructure. We have no hosting at the moment. When you go to Graphite, you are visiting just a CDN, just hosting static assets, meaning that we don't have to pay for anything like that because it's free to host just purely a website with static assets. But as soon as you get servers and databases and computation on the cloud, then it becomes expensive. And of course, that's something that we'll have to be able to support and scale up and maintain balances and load. And it gets all very complicated in terms of both maintenance and cloud costs and things. So that's going to be a transition that we probably are going to need to hire someone to work on full time as part of their allowing us to go from what we're at now. It's just purely a client side application to eventually having those kinds of infrastructure for like the asset store and stuff. But that will be a transition up in the future. But yeah, that's kind of a word on business models and how we intend to make this project as big as it can possibly be towards making that ambition realized.
Well, since we're on the topic of business models, what is the actual structure of the organization that runs the project?
Yeah, so basically we want to keep as little overhead as possible. So I've simply formulated an LLC, or organized an LLC that I'm the sole owner of, and that just allows us to have a bank account, so I can, buy like my flight here, for example, to Germany. I'm normally based in California, and so far I've had to put in some of my own money to get us to this point, but I'm hoping to get that money back through donations, and also Google Summer of Code gives both grants for our students to basically hire interns for us over the summer, and they also give our organization a bit of a stipend as well. So with that plus donations, I think this year we might very well be slightly positive instead of slightly negative like we were in previous years. But yeah, basically I'm just the sole owner of the LLC, and it's not really a company that's a company that's run in a for-profit way, even though technically it's not a nonprofit, just because there's a huge amount of legal overhead and requirements and things to run that. And I am not a lawyer. I am a programmer and I'm a designer, and I don't want to even think about any of that stuff. It's hard enough to just run the basic stuff. But we could always become some sort of nonprofit foundation in the future. It's just a matter of what kind of priorities make sense.
I think right now the priority should be getting something that people are wanting to use and doesn't have a constantly changing file format. And I understand why you're in the position you're in. Like it makes sense why you're doing it the way you are. I know some people want it done perfectly from day one, but I totally understand why you're coming at it from the direction you are.
Yeah, it's back to that analogy of painting a painting, and it takes 100 years to paint a specific painting, and you can either paint that 100-year painting square inch by square inch in its completed detail, which is basically impossible, and people have to wait 100 years to see your painting, or you could do incremental detail levels, strategically working on specific areas. Maybe you get to see the face before you get to see the body, and the face is what you care more about than the body, but you ultimately have to pick what you're working on first, and we've so far picked on, I think, a pretty good, I wouldn't really do many things differently if we were to have the benefit of hindsight. I do actually think our strategy has been quite on point. But we've really focused on first building an editor, just like something you can interact with at all. So the UI, the buttons, the tools, that kind of thing. Then we went on to move towards building the graphics engine. So we replaced some of our temporary vector editing tools that were all just sort of rudimentary vector editing tools with ones that would use the node-based graphics engine. And that graphics engine, this is Graphene. So Graphite is the editor and the project. Graphene is the engine / language / you could think of it like the Unity editor is Graphite, and the Unity game engine, like the thing that compiles your game, is the engine here, and that's equivalent to Graphene. So that's kind of what we're building here, two separate technologies, and Graphene is just as ambitious as Graphite. They go really hand in hand, and we have to build both of them, and Graphene is going to be a 20-year kind of project to reach its full final ambitions in the same way that Graphite will grow alongside it. And we can't just build graphics editing without building both of those together.
Okay. I want to jump back a little bit. So we talked about node-based editing, and I think it's fairly self-explanatory, but just for anyone who doesn't understand, when we say non-destructive, what do we actually mean by this?
So let's say you are going to draw a shape. Let's say you're making Pac-Man. So you draw a circle, and then you cut out another circle from that circle. You're creating like a pie, like a crescent shape. So you might start out with two circles that you have to draw, both of them. Then you have to cut one out of the other. And the exact position of both circles in relation to each other will result in the final crescent shape that you made. In other graphics editors like Illustrator or Inkscape, if you are going to draw those and then cut one out of the other, doing a Boolean operation to subtract one from the other, that decision about where you placed them, what those shapes look like, whether they were even circles to begin with, or if they were some other shape, like a star, or anything you drew with a pen tool, those are all decisions you made. And the operation of cutting one out of the other was a destructive operation. You have permanently transformed two layers into another new resulting layer. That operation is ultimately a function. And in those other pieces of software, you have you perform that function, that operation, in the editor once at the very moment you press the button to do it. In Graphite, what that does, by comparison, and this is what makes it non-destructive, is that you have added a node to your node graph, which is that function. So that function that does the operation of cutting one out of the other, it's encoded into your artwork permanently from that point. Obviously, you can go delete it, but the operation is not, I made the decision to cut it out once and I've transformed my data permanently and lost the original layers and got a new layer in return. Instead, it is, I have replaced, I've put together two layers and then combined them into one with, basically, if you think of it like a flowchart, because the node graph is basically a flowchart, you take the two layers, make them flow into one layer, make them flow into one operation. That's the node that does the Boolean operation. And out from that, you get a resulting layer of those two combined. And now, since those are permanently part of your flowchart, unless you delete them or something, that operation, now if you go modify the crescent shape, like modify either of the two circles, you can create live, like, every frame while you're dragging it around, you see the resulting Pac-Man shape or crescent shape or whatever, and you can just drag it around live and see it update. So that ends up being really powerful. And then you can go non-destructively add, let's say, a bevel or like a round corners kind of operation. And that node that provides the round corners can then go and add like a rounding to where the Pac-Man symbol, got its crescent corners. And then you can still drag around the circles, and those crescent, the crescent updates and the sorry, I'm thinking when I say crescent, Pac-Man is a pie slice, not a crescent. But anyways, my point remains. Cutting a triangle out of a circle is what I meant to say this entire time. But yes, basically you can update it or even animate. So this is the important part, because everything is parameter driven. Exactly. You can animate the opening and closing of the Pac-Man symbol every frame. And then the operation that does the Boolean cutting of one out of the other can animate over time, and you get the resulting shape out of that.
Now, with these nodes, is it just a linear connection of nodes, or can a node have multiple inputs into it? So say I have a bevel that I want to apply, and I want to apply this to multiple different elements in my image. Am I able to send multiple things into that bevel, or do I need to duplicate that node?
Okay, that's
2 questions.
Yeah, that's sort of 2 questions, or there are 2 answers to that.
Okay.
One is that you would want to duplicate that node because the bevel takes a single input and gives a single output.
Sure.
And if you wanted to do it to 2 independent shapes, you would independently provide that. Although we do have some designs in mind for kind of like creating like a placeholder node that can be driven by the definition from a different node.
Right. Okay.
But we haven't really designed an exact solution to that. But that is a case where we're aware of that being sort of a common use case. But what you would do right now is you would basically make multiple bevel nodes, but you feed the bevel radius parameter from a single number, and you feed that in to multiple times. That's a multiple of the bevel nodes.
And I guess what you could also do is that you just combine both of them.
Yes.
And then you can apply a bevel after, like, to the combined output.
Sure. Okay.
If you have, like, we can have a square and a rectangle, and or circle and a rectangle, and both of these are one set of input data, and you can apply a bevel operation to both shapes, essentially.
Okay. That makes sense. I was just like, my main point there was that there are going to be cases where you want to make use of the same effect across different things, and just making it clear that there is some way that you can do that isn't just, copy paste it 100 times to everything you want to apply it to.
Yeah. And that's like, one of the things you can pretty easily do in Graphite is, for example, generate patterns. If let's say I have a circle, and I then instance it by repeating it 10 times along the x-axis. Now I have 10 circles. I can also repeat these 10 circles like 10 times in the vertical direction, and now I have a grid of 100 circles. And I can then do operations on these, like on this grid of circles. That's something that's very easy to do in Graphite, and you don't need to draw 100 circles.
Yeah, this is an example you have in the documentation under the Learn section, the idea of doing procedural design.
Yeah.
And of course, you can go update that circle and change its radius, or actually replace the circle entirely with a star or with any other shape that you want to make. And you keep all those other effects, all the repeating part of that process. And it allows you to then, you could also go target one of those circles and make a change just to that one circle. And then you could still change the number of repetitions in the horizontal or vertical axis. It gives you the ability to modify at any point in the pipeline, because you're basically in the process of drawing things. Normally you'd just draw destructively, but in this case, we're creating a pipeline out of the creative operations you chose. Like, I want to repeat something. That would be a menu that you do once in Illustrator or Inkscape. But in our case, we encode that operation that then becomes editable later on. And then you could still make your subsequent operations. You can still edit a specific resulting shape out of the 100 that got created. And that allows you to still, target specific pieces. Or it also just generally saves you time, because, copying a circle 100 times, that might be a common enough use case that Illustrator or Inkscape, they've got a menu that allows you to just do that. It's a tool that they've built that does it one time. But in many cases, you need to be able to combine together many tools to produce some resulting shape, or some resulting visual style or appearance or output that is not possible using the existing tools that have been built into the menus and different things. Or maybe they had to hide it behind so many menus that you were not aware of it, and
Right.
you just never learned that.
And it is another example of building automation on top of the editor, like automating the editor interaction. And what we do instead is that we just treat it as a program, and we can just duplicate it, and that's fine. We don't need to build UI for that.
Yeah. So like one of our examples, if you actually go to our editor and you open up some of the demo artwork, we provide some demo artwork that you can use. We've got this example of a Christmas tree where we've decorated the Christmas tree with some Christmas tree lights. And if you were to draw that by hand, you would have a bunch of light bulbs. You got to like copy a bunch of light bulbs all along the distance, the arc length of the Christmas tree light, and that would be tremendously painful to do that, because you'd have to like take literally a ruler out of your desk drawer, take a ruler, measure the distance from one light bulb to the next light bulb, and then to the next light bulb on your screen, because there really aren't any other tools built into Illustrator or Inkscape that I'm aware of, at least.
I mean, there's
maybe
the
there
ruler,
are.
There's the ruler tool.
I guess, yeah, but
you wouldn't need to use a physical ruler, but
and then maybe you end up with like 50.3 light bulbs by the end of your by the end of the strand, and like, oh crap, I ended up with 0.3 at the end. Now I got to like go undo my work and go, instead of making it like every inch apart, got to make it like every 1.05 inches apart, and like, do the whole thing again until they line up nicely. And then you decide you want to modify the tree or the light just a little bit, and now your light is a different length, your wire is a different length, and you got to update everything again. So that would just be a use case that is just super difficult and painful to do, and it would not look as nice because you never measured it perfectly. Whereas in this case, you have combined together, I don't know, like 3 nodes or something. One of them basically takes your wire, the path wire, and splits it up into basically a polyline. It splits it up into equal length segments. And then now you've got basically a point equally along the wire. And then we copy a light bulb once. We design the light bulb once, copy the light bulb, and then it gets placed automatically everywhere that those points were located. So now you're reusing the wire, both to display the wire visually and also as input to the data for the operation that dealt with placing the points. And then finally, we have another node that can take all the resulting wires and apply different colors to each wire incrementally. So you can then define a gradient and say, okay, along this gradient, we go from like red to green to blue, and it recolors every wire incrementally. So you could either have it like every 3, where it's like red, then green, then blue, or you could say across the entire length of the strand, we slowly transition from red to the intermediate colors to green, to the intermediate colors to blue. And that just makes it so you don't have to do that by hand. And I don't think there are any tools that will incrementally change the color of every object that exists in Illustrator or in Inkscape, because that is just a use case that they never envisioned you'd need. And if they did, it would be really hard to define that in a way that exists as a tool. And there are so many specialty ways that you could make these different tools that they could never like design a UI for every possible thing out of thousands of use cases that they might anticipate a user might need. Whereas in our case, you get to combine together these little operations. One of them was like an operation that split apart a wire into many little segments, and another was copying something else onto a segment. And by combining together little pieces into slightly bigger pieces, you build up you build up a pipeline that allows you to learn little pieces of an overall system. And of course, there's some learning curve knowing what's available, what operations you're able to access, what nodes. But you get to do so in a way that's kind of incremental. And this is how we ultimately, the really important part, avoid the curse of feature creep, where feature creep or feature bloat, I guess is the word I mean, where a piece of software just becomes bloated with so many different menus and buttons and things where it was never designed for all of this. That is the problem with big software, where they just keep adding more and more features to it. You never know what features exist hidden behind so many menus because you just never encounter them. They're just so hidden. They have to be hidden because there are just so many of them. In our case, we flatten out that complexity by just having all these little atomic operations, like little pieces, elements of an overall molecule that you can combine together and make the things you need, and you can make reusable systems out of them. Combine together the common operations into slightly more complex operations that do higher level things, like create light bulbs for you. Or you could change that light bulb by just updating, drawing a different shape to the light bulb, making it icicles hanging from rafters instead of light bulbs hanging from a tree. Reuse that system, and basically that way we flatten out the complexity to make software that is, despite its extreme power to do much more than is possible in Illustrator or in Inkscape or in Photoshop or in After Effects or in basically every program that you could specifically think of where it's built for one specific purpose. Since we've built a game engine, but a graphics engine, it is capable of you can make any game that you would ever want in Unity or in Godot or in Unreal Engine. They're not limiting you to one specific thing, but of course it requires a lot of programming. What we're bringing here is the tools that can do that programming sort of on your behalf. You don't have to touch the code.
And on that note, on programming note, we do also support some sort of programming use cases. So one demo we have is a FizzBuzz program. So FizzBuzz, classical test for computer scientists, where you, if the number's divisible by 3, we output fizz. If it's divisible by 5, we output buzz. If it's divisible by both, we output FizzBuzz. And you can do that in Graphite. We do have nodes. For example, we have a switch node, which allows you to, depending on if there's a Boolean is true, use this output or this output. And this allows us to do some pretty cool stuff. So one of the examples, one of the demo artworks I did for the FOSDEM conference in 2025, was I made a 7-segment display in Graphite. So I took a year input and
as a slider, and by slider we actually mean like literally use a circle in the canvas with a box, like a horizontal rectangle. That's the slider, and you get to move it left and right. And
then we use the centroid node to get the position, and we can just use the position as an input for our 7-segment display. And this allows us to build like a counter in Graphite. And since then, and since we've added animation, other users have made a real-time clock, for example, with a 7-segment display, and that's also really nice.
Now, I'm not suggesting someone. I'm not suggesting someone does this. Oh, yeah, but I'm not suggesting someone does this, but someone could, if they wanted to, try and make a game with it. A simple game.
Yes.
You shouldn't.
So here's where
we'll need to talk about this because I have doubts, but
so this sort of, I mentioned at the very beginning of this that I sort of got my start in Flash. That was kind of my first real experience working with interactive graphics and games and animation and things. My sort of formative years in computing. And Flash never intended to be a game engine, but by the end of its run, people would have described it as kind of the first generally accessible game engine. This was before Unity really became popular or available at all, actually. And you could make, web games, mostly focused on 2D. I guess they had some amount of 3D, but it was almost entirely 2D. But it was a 2D a 2D game engine that was never intended to be a game engine. It was intended to make like little like slideshow kind of presentations or like slightly interactive buttons or like, little graphics, things that back in the day could have been equivalent to like, do you know the name of what Apple's, like the program that Myst, MYST, that was originally built in? It was like this interactive way of like going between different pages and clicking buttons that bring you to a different page. And then that has some information, some either visuals or auditory or text. And you can click on a different button. And people ultimately turned those systems into full-on adventure games like Myst. And then eventually that sort of idea became, Flash. And it's like, oh, we can embed them on websites. And turns out people can start using them to make little games. And then, of course, they started adding more and more features to that. So by the time Macromedia stopped running that, and I guess it got bought by Adobe, then we ended up having continued to, it basically became more and more of a game engine until the end of the era, I guess in the early 2010s or early 2010s, when that sort of heyday ended. And that was when I was growing up playing lots of Flash games. I loved that era, and I have a lot of nostalgia for that era. But then Unity took over and Flash faded out of existence. It still technically exists today, but it's not used for really anything except making just animations. I think it's used for like it might be used for animating South Park, but I could be wrong on that. Anyways, it's used for some actual animations used in like TV, but it still exists today. But it's called Animate now. Except it really isn't used for games because that sort of moved on to Unity as kind of the main game engine. And a lot of it also, we've lost 2D as much. So unfortunately, there are not as many 2D games in existence these days. But the ultimate byline here is that they started out with something that wasn't a game engine. It was just an interactive graphics engine. And they ended up with people turning it into a game engine. And in many ways, we're actually kind of reviving that same idea where we're kind of making a graphics engine, which has some interactivity. You can do animation, you can do real-time input. One thing I want to hook it up to is audio inputs. So you could like do interactive audio visualization. You can hook it up in the future also to like a webcam input and start doing like machine vision processing on the image to like, hold out your hand and then like have it process where your hand is and like put some kind of augmented reality thing over your hand, or do like interactive compositing, or even like take your Twitch stream and a donation comes in through a webhook API. We notice that there's this person gave a donation for this number of dollars. We generate like a visualization that pops up and says, thank you to this person. And it processes the feed in real time.
And you can build that visually in Graphite.
Yeah, there's no code involved.
Exactly.
And then ultimately, we could also then have basically a play mode where we stop directing your keyboard input to the tools that you use to draw. In the same way you hit play in Unity to play your game, you could play keyboard input and mouse input going to the actual program that is your node graph system that does interactive graphics. And you can basically maybe start making like small games, and then we might have more features.
I am
we'll have
watching
like a
the
physics
gears
loop.
turn in Dennis's head right now.
Yeah.
He's like, oh god, this sounds
Well,
incredibly
He has objections
complicated.
to the effort involved.
So the thing is, Graphite, like the graphene language, is purely functional, and that's partially because during the time that I came up with the initial ideas and developed graphene, I was taking a course on functional programming language and other language paradigms, and programming language, like functional programming, lends itself very well to this node graph use case, because we can parallelize the entire node graph execution. We can cache things. Our nodes are required to be idempotent, so basically pure functions. So everything, we don't have state in the node graph,
right?
And that is a bit at odds with the game engine. So what you need for a game engine is you can't just use graphene. You need an editor component which holds the state, and then we can render the state. Like we can be the renderer for a game engine, but there won't be the interactivity in the node graph because it wouldn't be a functional, it wouldn't be a pure function essentially. And that is something where we can build infrastructure and tooling, but yeah.
That said, we will have sort of a node that can act as kind of like the holder of a bake. And you can bake something like a physics simulation. You bake frame 1, then you bake frame 2, then you bake frame 3, then you bake frame 4, and so on, holding what continues to grow as a larger and larger amount of state, and that becomes an update to the graph. So the graph now holds this previous state, and that way you can have your full physics simulation running for the 500 frames you might have generated it for. And that way, you can do like sloshing liquid or some kind of cellular automata or some kind of interesting visuals. And
I guess that's also maybe a good point to talk about how animation is implemented. Like we do support some animation, and the actual implementation of animation was very simple. Like it was a pretty small PR, and basically what we do is
it was an emergent property of an existing change.
Yeah, exactly, and that's how we always wanted to design the system. So basically, we have a program, and we can say, I want to render this program at this viewport, position and resolution. What we can also say is we want to render this at this point in time. So again, getting a bit more technically, the entire Graphite document is a function, and you call the function with like the position and the time information, like the current time. And then the main function calls its subsequent functions. We pass down the time as an input. And how you enable animation in Graphite is that you just have a node which returns the current time
as a number in seconds.
as a number. And you can then use that number to, for example, modify the rotation of a spinner or something.
Yeah. Or you can run it through a sine wave node, and that way it takes everything from 0 to 360 degrees and outputs
repeats.
from -1 to 1 over a continuously varying smooth wave sequence.
Exactly. And that's sort of currently it's pretty technical because we just have this node and you can basically do anything with it. But it would, of course, be useful to have more tools. And that's something we will work towards.
Yeah, like
Getting-
keyframe animation.
Yeah, keyframe animation, getting timelines. But mostly animation is just an emergent property of the graph. And you can still, it's really fun if we have animations of balls juggling around, and you can, while the animation is running, still modify like the balls. You can move them around. And
Do you have a
pretty
is any of the
fun to play
demos
with.
in animation?
None of the demo artwork at this very moment is animated.
Okay.
That is something
change
that
that.
I think we intend to change very soon. So
Okay,
depending
cool.
on
I
when you're
just wanted to
watching
show
this, you
something
might
on
end
screen
up-
if I could, but
Yeah.
that's all good.
Yeah, can send you some files at some point. But
Oh yeah, awesome.
Yeah.
as fun demos.
But there are definitely some really cool animations you can make at the moment. It gets into the territory at this very moment of what's supported, where it's basically creative coding style animations. You'd otherwise have to go write some P5.js, JavaScript kind of code or processing or whatever if you're in Java. Make some use some frameworks to produce creative coding style animations, which there's no other way to do it really. You can't hand animate this stuff, but in Graphite you can hand animate purely using the node system. And also, it's something you could do is you can easily go like copy a specific object 500 times and have every iteration of the 500 versions like modified slightly. So you could have like a different angle and like a different rounding to the corners of something, and you basically build up like this propeller thing that looks really 3D because you also apply different colors to every version of the 500, and it starts looking 3D because if you have enough of them, they start not looking like discrete objects, but they look like more of a continuous 3D kind of depth shadowing kind of shape, and you end up with having all of that, actually looking like a 3D object that is pulsing and doing interesting things that would not otherwise be possible in anything except creative coding, where you have to write your own code.
All of that sounds really impressive. Your camera is
really
like
fun to work on.
out of focus, by the way. I just noticed that the camera's out of focus. Okay, now we're good. Cool.
Okay, thanks.
Yeah. No, all of that sounds like really, really, really cool. And yeah,
There's no other software like that I'm aware of. It's actually quite novel.
Yeah. There's a lot to. I guess there's like a lot to take in here, right? Like this is. I have had developers on who are very passionate about what they do, and I've had people that have like big visions for their project, but I don't think I've spoken to anyone that is this committed to the idea of basically revolutionizing open source 2D graphics. Revolutionizing 2D graphics just in general.
Yeah. Basically our strategy here is that we know that we can't compete with 35 years of creative software that's been on the market this entire time and is totally entrenched in every piece of industry. We know we can't compete just by trying to catch up to them, by implementing as many features as they have. That's been already tried by other open source projects for the past 25 or 30 years as well. Like they started almost in the same era, but you just can't keep up with a big company that has already maintained so much market share. So the only way to actually compete is by trying to flank them, by going around them and getting in front of them by taking a different strategy and having features that they do not have. So you're not trying to compete with the same features by simply trying to have feature parity in every possible way out of their thousands and thousands of features. You want to make something that is even bigger, but simultaneously more powerful. And you can maybe make something that is commonly used between both pieces of software. So industry might be using existing commercial open source standards. I'm sorry, commercial standards at industry standards. Thank you. And at the same time, using Graphite alongside it for the things that they could not do if they wanted to do interactive, like templated style systems where they have, every player on a sports team out of the thousands of different players across an entire bracket for a season, having their picture and their, holding a basketball or in one frame, and then they're, I don't know, smiling in another frame with a headshot. And then they've got to export that same image for like 500 different member stations that need different resolutions based upon what their broadcast standards are. They got to have like 480p for standard definition, or they got to have, interlaced and non-interlaced file format outputs. I actually read on Reddit someone who had a job for a few years. This would have been some time ago. His job was literally to go in Photoshop and click on menus to export like 60 different variants of a template for each individual player at different resolutions, different export formats. You had to go like modify it each time, export it, and his entire job was just doing that, clicking buttons. And that's the kind of thing that you can just so easily build a pipeline in Graphite. You just have every one of these different formats as an export, and then you just hit your export. And that was why I was mentioning like a render farm. In that particular case, if you really have, like 10,000 variations that you export, all the permutations, you could set up a pipeline and get that to run on a server, and then get that to automatically ingest into your media server if you're, a broadcast company. So that's the kind of use case that we see in industry where traditional tools, Photoshop, like this person on Reddit, I was reading his story, you otherwise have to do it manually. And yeah.
And there's, going back a bit further, we were talking about like we can't just catch up. And also one of the key strategies is that we are a community project. Yeah. So what we're trying to do is that we basically build the environment, we build the node graph, we build the execution engine to make it very easy to add features. So if you want to add a new node, so one of the nodes, for example, that we will add soon is vectorization. So taking a raster image and turning it into vector shapes. And that is just, it's a single file that you add, or can add it to an existing file. It's just basically one function, the vectorization node function. And then it shows up in Graphite. And the idea is we build the tools, and then we can have, the community can help. And if they need a feature, they can just build a node. It's relatively straightforward, and the DevX is actually pretty good, I'd say. And that can help us catch up. And we don't have to build everything. We can enlist help from the community to build things together.
We're building the engine, and then the community can build every individual feature as a node or as a tool that operates on the nodes. And those are like the two components. There's the nodes themselves, those are the graphics operations, and then there's the tools that are basically the artist-friendly abstractions where you don't have to go manually write the visual code. You are instead just drawing or using a menu to operate on something. You apply the Boolean operation menu button, or we have a button, or we also have it under the edit menu. Both of those are just operations that you would be expecting to find in other software just using their menus. We want to put them in similar places. People could find them using similar means. And it sets up the nodes for you. Or it might even set up like a complex set of nodes. You might have like 5 different nodes get put together for you to do a specific common operation. And that way you don't have to know how to do that. Yeah.
Okay. I had something I was going to say, and I don't remember what it was now. Yeah.
When was it?
It was like 3 minutes ago.
Was it during one of what Keaton said, or when I started taking over?
I do not remember. It's gonna come back to me probably after we finish recording, probably. That's fine. We'll leave that behind for now. We'll maybe come back to it if I remember it. I do want to talk about desktop binaries. So when we're talking about the,
I'm going to take a bathroom break and actually have our contributor involved specifically in our desktop app. He's our maintainer.
Well, do you want to appear on camera or not?
I'm not prepared, really.
So we're going to talk about the desktop binary. You can at least listen in.
Yeah, okay.
And if you want, you can hop on or not. So, well,
Probably next time.
all right. So we could also have you off screen if you prefer and just want to speak.
Yeah, okay.
Yeah, right.
Okay.
We'll just have me with my disembodied voice to the left of me.
Oh no, they can join on camera, I guess.
All right. So now the Germans have taken over. So
The Germans have taken over, I guess.
this is
Um,
Timon.
Yes, do you
and-
want to briefly introduce yourself, and then we can talk about the packages?
Yeah,
You'd like
I'm
to sit a bit more there, I guess.
near.
You don't
Yeah, okay.
have to be
Yeah, I'm Timon. I'm also from Germany, and I were mainly working on the desktop app for like 3 months now,
Mhm.
I guess.
Yeah.
And yeah, I'm a NixOS user and also been building the NixOS package on the side. And yeah,
You can maybe tell us a bit about your background and how you got introduced to the project or joined the project.
yeah, I was using Graphite for about 1.5 years, very heavily for like all my art stuff I do on the site, and I was annoyed that there is only a web app, and then I joined the Discord and asked around how's the state on the desktop app, and then we joined a call sometime, and I found out that the desktop app is kind of not ready at all.
Yeah,
And
so
that we would
there were some very challenging architecture things. So what we want is that we basically run most of the code natively, and that means that we then have we render the node graph, and we need to composite the render output together with our UI, because the UI is still in web browser and rendered as web UI, and there were no tools or frameworks available to stitch those together. We did at some point have a demo where we could pop out the viewport into a separate window, and then we have the main window and the separate window with the viewport, but that's obviously not ideal. So when he joined and was asking about the desktop app, that's also why we weren't prioritizing it and working on it, because there were just technical hurdles. But around the time, or shortly after, we did some new experimentation using CF, so the Chromium Embedded Framework, which gives us a bit more low-level control. Essentially, what we're doing is that we render the browser UI to a texture and then do our own manual compositing in a graphics pipeline. And
like it's a VGSL shader that overlays 3 textures and displays the final result. So the the artwork and viewport, like the whole viewport, is one texture, then overlays, and then the UI, and that means we have the viewport with full native performance, and only the UI goes through the CF latency stuff, and
yeah, and also one of the technical challenges we overcame is that we render the texture off screen, the UI texture off screen, and keep it as a GPU texture. So on Wayland we use DMA buff protocol to get the texture, it remains on the GPU. We can copy it over, insert it into our program, do the compositing, and that allows us to get pretty great performance in the desktop app. We're still working on improving that, but yeah, we're making great progress.
Actually, the code that was written to do this, keeping the text, like the UI texture on the GPU, that will probably be upstreamed into the CFRS crate very, very soon, because they basically were able to use our abstraction and build it into the API. And
because that's also OBS use a similar approach. So OBS also uses CF.
It does, yes.
And for some of their web view, web content rendering, they also use
web docs.
Yeah,
they don't work on Wayland right now.
And and they work on Windows. They don't work on Wayland. I looked at the code, and well, there's no real technical reason why it doesn't work on Wayland. The work just hasn't been done yet. So I basically did the work and it works. So that's good. So potentially that's also something that OBS could do in the future. But yeah, doing then in this a desktop app, even though we do as minimal native desktop interaction as possible for the UI currently, it's still just a bunch of work.
Right.
Because there's a huge difference between getting like 80% working and getting the rest.
Oh, camera just turned off.
Yes,
Oh.
Is the camera overheating?
Possibly.
Oh.
It should be plugged in. Did I forget to plug in the
power cord, maybe? Professionals at work.
I love it.
In the meantime, we can momentarily switch the camera to.
That looks amazing.
Can you fix it? We'll switch to the webcam for now. By the way, up there you can see our main CI server running. It's just.
I love it.
Yeah, it's a great setup. But yeah, so going all the way with windowing, and it's really difficult. And you can tell us a bit more about what it took to get it working with client-side and server-side decorations and windows. It's
Yeah. So I think I start with the Wayland side. Basically, Wayland doesn't allow you to hit test where the mouse is when it's outside of your window, so outside the pixels you draw yourself. So we basically need, if you want to have resize borders that are outside of your actual UI, you need to draw a bigger window and then hit test on invisible pixels that are not shown in the compositor. That's mainly for like KDE, GNOME, and not really a thing for tiling window managers, but like on the desktop environments. And that was basically a use case where we have like the use case of having a custom title bar, but still using a resize border and shadow that is supplied through a upstream, like a library that winit, the crate we use for window creation, is using. That's using like a visually similar style to Adwaita. And I actually needed to upstream a feature flag to support the use case of still using these client-side decorations for shadow and resize borders, and for the click testing to work, but disable the custom or the Adwaita style title bar and use our own. And that was not that painful on Wayland and X11, but it's extremely painful for Windows, because on Windows there's the same thing. You can't hit test outside of the window. So you would need to draw your own shadows and do hit testing on that area. But getting shadows to display the exact same way that Windows is normally doing that, so it looks kind of like a native window on Windows, is very difficult. So we opted to use the still use shadows and use a kind of hack to draw over the parts that Windows supplies, but that disables the resize borders. Shadows still work, but the resize borders doesn't work. So I actually need to we open a second window, an invisible window over our own main window, that is slightly bigger, just for hit testing, and thinking that every time we resize or move the window, we move that like invisible window with it, and then we have resizing and shadows that way. And then we also have weird edge cases where when you maximize a window on Windows, Windows actually cuts off part of your window depending on what exact window version you are on. So they cut off on the top 20 pixels on Windows 10, 30 pixels on Windows 11, and you basically need to offset the like the frame where you draw your own pixels so that the part they cut off is just invisible. And it's very weird, but all Windows like Microsoft apps do it the same way, so it's kind of a hack that got into made into a feature. Even today it's done that way in the official docs, so maybe they support it now. Yeah, actually, when you try any Electron app on Windows, even VS Code, like a Microsoft product, they do resizing wrong, and the resize border is inside of the UI and not outside. So we are actually doing better resizing than a Microsoft product like VS Code.
Right.
Yeah. It was so annoying. So annoying. Yeah.
So, the main
And
thing...
I'm gonna
Go on.
I'm gonna start working on the macOS version very soon. That was not really tested until now, just because we didn't have access to a Mac device, and I expect that to be and very annoying as well. Yeah.
So the main thing I wanted to ask you about, obviously, like Windows and macOS, they have their formats. It's a pretty set format. I don't know if you guys eventually want to be on the Microsoft Store or whatever, but when it comes to Linux, what is the intention of actually getting the application available? Is it going to be getting it into distro package repos? I know you've talked about doing a NixOS package. There's talk of doing AUR packages as well. Is it just the intention to do distro packages, or is there interest in doing like app images or flat packs? How
I want to basically I want to have an package on FlatHub and an app image that people can download from GitHub releases, and hopefully also a just a tar file with like all dependencies included. Like CEF is our main dependency. For other distro packages, probably not done by us, at least until like people get on board that want to maintain those things, because packaging is a lot of work.
Right.
Actually, probably people are watching that might be interested in doing that someday. So probably support a lot of ways of installing Graphite in the future, but that will
There we go.
need to... Yeah, nice. We'll definitely need more people on board that can do packaging for that to work.
Yeah.
But I will work on the Nix package because I use NixOS, and we'll probably have a AUR package at a similar point in time, right?
Yeah, probably. I think AUR packages should be relatively easy, and we don't need to go through as many processes to get that approved. Another thing we are looking into is potentially distributing through, for example, Steam to get versioning, or like on Windows, potentially the Microsoft App Store, because we do need to, or want to include some form of auto updating, and ideally we don't want to build that ourselves if we can avoid it.
Okay. You've gone out of focus again, by the way.
Yes, yeah, I'm out of focus. Could you try? yeah, we have Kevin, our camera technician, on standby. He's trying to fix the issue as soon as possible.
Mhm.
Um,
Yeah. So, when is the hope to have a desktop app?
I think ideally by the
There
end
we
of
go.
this year. Yeah, it's focused. Good. Yeah, so ideally by the end of the year slash if we. Oh, it's still a manual focus because I think
It's not manual focus.
Oh, right. Yeah. So ideally by the sorry. So probably by the end of the year, and when we do our next big launch, we will probably do some sort of beta testing before then, to get some alpha testing for the desktop app, just to get some more eyes on it, test that it actually works on different platforms, get macOS support working. But yeah, currently it actually works best on Linux, which is kind of nice. And that is due because like we both develop on Linux, but that's great for the desktop app and for the Linux ecosystem.
Okay.
And NixOS is currently the only OS where we have a package basically ready.
Yeah.
Yeah, I know there are some Fedora packages that watch this. I know there's some Arch people that watch this. So obviously early on right now, but sometime. So you guys aren't opposed to having distros having their own packages for it. I know some projects are like, we want to do our own packaging. We don't want to have distro packaging. Like we're not gonna support that.
I mean, in the end, it's an open source project, so people can do what they want. But we do prefer if they get in touch with us so we can make sure everything works, just keep in sync. But we are definitely not hostile towards distributing Graphite.
Okay.
We want Graphite to be available in a way which is most convenient for the users.
Okay, I think that's pretty much all I wanted to ask about the desktop application. Yeah, thank you for that.
Okay.
And Kevin does not know what we were talking about because we only have 2 pairs of headphones.
Oh.
So
Yeah. That said, we do want to be sort of the authoritative source so people know where to get the official distributions so we can make sure that they're always meeting the same bars for quality
Sure.
that we intend. So we'd rather not fragment the ecosystem, make sure that we are able to provide high quality to everyone and they know where to get it. So if we can support more distros or more packaging formats, it's effort we have to maintain, but we do intend to maintain as many distributions as possible over time. So we'd rather people help us do that instead of doing it on their own without getting in touch.
Okay. So what sort of attention has the project really garnered so far? I know obviously the GitHub has 22,000 stars. Again, I don't know how it managed to get there without anyone telling me about the project, but
Yeah, I would say right now it is accurate to describe Graphite as a project that has largely flown under the radar of almost everyone. And that's a blessing and a curse. It actually has allowed us to kind of just let things cook. And that is in many ways good because we have really ambitious goals. And if we were sitting here telling you the intro, the first half hour of this podcast 3 years ago, it would be a lot of hot air. But we've built a sizable portion. It's only 1% of the true grand vision, but we've got another 99% to go. But hopefully we'll have a bigger team to get there faster. But it really is helpful that we've been able to just sit there and kind of cook without people getting too angry at us that the software's been crap this entire time. Only the past year has it actually become at a performance level viable to use the editor for more than just testing. But now it's actually the performance is decent. Some people have even said it's better than Inkscape. Some people have said it's a little worse than Inkscape. It's around the same level-ish, and it will continue to get a lot better because we have barely even touched the low-hanging fruit. There's a lot more low-hanging fruit to go, which means that it's even easier to continue making further improvements. And we are really building the architecture and the core technology here with the specific goal of allowing you to work with terabytes of data someday. It might take an hour per frame to render something of that size, but the point is to handle that kind of scale someday. That is the performance goals that we have in mind. So it should be the highest performance graphics editor available someday. That's what we're building towards.
Is there anything else you guys wanted to touch on, or is that we've sort of touched on a lot of stuff, but anything we didn't get to, anything we kind of missed?
I mean, I think that's probably been a pretty good overview.
We didn't talk quite about the compiler yet. So the ability
yeah.
to basically create a piece of artwork as a program and then compile it to an executable, like a standalone, completely standalone executable.
Okay.
That can either, for example, run as like the equivalent of a full screen game where you double click on, if it's on Windows, you double click on an exe file, or on Linux, you open it however you open an executable that would launch full screen. And it would like run full screen probably forever, unless maybe some way to terminate. And it could, for example, be a game, or it could be a live visualization of music, or it could be maybe you have it running on some kind of interactive exhibit with a projector screen and a camera that's receiving your video feed and like noticing where a person's walking by and creating like butterflies flying onto their shoulders or something with a projector projecting onto them. So it could run full screen as a standalone program, just like in Unity, it will or Godot or any game engine compile a standalone program. It's not using the editor anymore. It allows you to do the same thing where you are creating. In this case, it's basically a sequence of Rust functions because we build it in Rust, so all the actual operations, the graphics operations, are running in Rust. They get compiled together into a sequence, and they can become literally a Rust program. So Graphite can transpile your Graphene program. So Graphene is the language that describes your sequence of operations, your sequence of nodes, into literally a Rust source code file. And then the Rust compiler can then compile that onto any platform as an executable. And it runs completely standalone without any connection to the original editor that it was built from. So that's a really cool use case that you can then have it. You might compile a birthday card generator because you might run like some website that generates birthday cards for people, and you can choose a template and choose a name, upload a photo, upload a birthday age, and make like greeting cards for people. And you run that on a server or compile it to WebAssembly, and it runs for your visitors client side.
And disclaimer, this is not something that is currently built. We do have the infrastructure in place, and
we prototyped it a little bit.
And we did something like that for I've built the basic flow, and it's like the basic feature set, but there is more work that needs to be put towards it because we at that point also need to have a runtime, because again, NodeGraph is functional, and if you want this to be useful, you need to have a runtime to accept inputs, etc. All of those are features we need to build, which are not don't necessarily interact with what we do in the editor. So it's extra things we need to build. But in general, the idea is to get as close to and this is also part of the bigger scheme. So as you mentioned, functions like nodes, we have two kinds of nodes. We have sort of abstractor, we have nodes which can be made of smaller nodes, so you can encapsulate node networks into node networks,
so
display them
node
as
groups
nodes.
basically in the Blender terminology.
That's similar to in programming how you would make a function that calls other functions as a way of abstracting features. So in the 7-segment display example I mentioned earlier, you could make every segment just be its own node, which receives a number and then displays the number. So you could abstract the functionality. Similarly, we can this is how nodes are built. Nodes are either consist of other nodes, like a node network, or they are basically just Rust source code, just a Rust function. And when you usually use the editor, we run sort of an interpreter. So the Graphite code is, we have these precompiled atomic functions, call these the protonodes. They are very primitive, or at least relatively primitive. And we then link them together at runtime to form one function we can call, which is sort of the document you can run. And what we can do instead is that we, instead of linking precompiled nodes, is that we basically copy paste together the source code just call the nodes in a sequence and then allow the Rust compiler to compile it. And one of the great avenues this allows us to potentially delve into in the future is that we can do jitting. We can, like if you have one branch of your node graph, which you rarely touch, but which is performance critical, we can ask rustc to compile this section of the graph into a node. And because it's purely functional, we know it's the same behavior, we can just do that and replace the function with this node and with this precompiled assembly. And that is something we can very relatively easily do on the desktop app, but is going to be a lot harder to do on desktop because
On web?
Yes, sorry. But it's going to be harder to do on web because the WASM target group is like the WASM working group is just not far enough along. And yeah, it's going to take more time until we can do that in the web. But on desktop, we could do it right now, essentially.
And basically that allows you to optimize certain parts of your execution to be even faster because you get to utilize compiler optimizations, LLVM optimizations, and get that to run even faster, getting down to like bare metal kind of performance for some of your operations. And then if you go like modify some of those pieces, then we just fall back to using the individual like sequence of individual operations instead of the precompiled version until we wait until there's enough time to go by where we have time to run in the background a compiler that will recompile that area once you stop touching it. And that's also something that could be a future additional part of our business model that basically anyone who wants someday to get like an even faster way to run their artwork, if they choose to, they could basically allow it to like stream the changes that they're making to their artwork to a server that we run and make precompiled pieces of code to substitute in those blocks of execution and send those back to you, send you like compiled substitutions. And that could speed up your workflow, make it run faster. And just another way for people who want to, if you don't want to be running that computation locally, maybe you're on a Chromebook, maybe you're on the web version, maybe you're on an iPad, whatever that is, you could ultimately just have things run a little bit faster. And then not only the replacements, but also rendering. We could pre-render certain areas. Maybe you haven't scrolled down yet, but we predict that there's a reasonable chance you might scroll down or zoom out or play the animation. We could pre-render specific frames of your animation or pre-render an area beneath where you're going to scroll to. And if you choose to support us, basically, then we can provide you compute resources to pre-render that stuff, send it to you over the internet, and let that run. Or also we have the idea to, let's say you have a gaming computer in your basement, but right now you're just working on your iPad or something. You could run it in your own local network, run like a headless version of Graphite, or maybe just keep Graphite open in the background. And because it's on your same network, you can use your own local compute resources to run that same kind of computation.
Or a CI server on top of the wardrobe.
Yeah, right back there.
Yeah. And so the way the Graphite language is designed will be, it should allow us to basically get zero cost abstractions. So theoretically, like we're not there yet, but we have not painted ourselves into a corner. I was made sure of that, and much to Kevin's dismay, but we can still, we can generate code that is going to be compiled into something that's very similar to what you would write if you just wrote it yourself, and basically becomes nearly optimal because of how we built the language and design choices, which make a lot of things harder from time to time. But we do always make sure that we don't limit our performance ceiling, essentially. That we can always eliminate all the overheads, even if that means we have to think a lot harder about how we do things. And there's one other thing we haven't talked about, which is also a planned feature. We can just quickly mention it, is collaborative editing. That is also something we want to support. So we do have some design ideas for how we can do the conflict resolution, but essentially live editing together, multiplayer editing.
Like Google Docs or Figma style.
Right.
Yeah, and also potentially if two artists work on the same document, make different changes, that's a question of how we can merge them together, ideally without users having to resolve merge conflicts.
Especially if two of them happen at different times simultaneously, like without a network connection between them. So it's not live, it's offline. You can combine those together with, like basically we're looking into CRDTs as the approach to that.
Yeah. And and if you ask, there's a list of things and potential features we could talk about. As we mentioned in the beginning, we are very ambitious as a project. But yeah, I think we do at some point have to stop because the video is going to be very long otherwise.
No, I am. I am really excited to see where this project goes. Both of you, I know you said that Kivon's kind of the visionary here, but both you are clearly like very excited about this project and have a lot of ideas for what you can do with it. I really hope that 5 years from now, I'm not making a WordPress style video about this project. So hopefully you guys keep doing really cool stuff going forward. And this really can be like, you know, the blender of 2D graphics, the OBS, the Godot, you know, any of these tools which are industry standard tools, even if, like you were saying, this doesn't replace Photoshop, but becomes something in that pipeline. You're not trying to do everything Photoshop is doing. You're trying to fit within the pipeline and provide a reason for it to exist.
Exactly. Yeah. And I mean, someday we can even perhaps add support for opening Photoshop files, modifying Photoshop files. So we could allow you to take your Photoshop document, do templating, like changing specific parts of your file with different text or things. So maybe you had a different artist creating some artwork. You could have our pipeline do the templating part for you. That's just another possibility that could be kind of interesting to look into. Yeah, when you make such a generalized engine, you know, the game engine of graphics, it just opens up all possibilities. And of course, we're not going to write everything. We're going to have an asset store, which will be kind of an ecosystem where a lot of the nodes, I mean, we will eventually have all of our nodes actually distributed through the asset store. So we update Graphite independently from how we update the individual nodes. And then you can have like versioning for the nodes and everything like that. So the nodes that we write and provide out of the box are going to be kind of a different part of the experience compared to the engine and the editor. And that way it lives alongside. And also we have no special capabilities that other authors don't have. So we're not making anything special. In fact, as we continue to build more and more of Graphite out of its own tooling, we're going to start basically having it so we can have it so you'll be able to like write more and more of its own UI, eventually replacing the CEF-based UI with its own UI. And then we'll have it so we can start replacing our own tools, like the tools that allow you to operate on the graph, with kind of like an API provided through its own graph system. And that way, all of the tooling and all of the custom UI additions, everything like that is distributed as nodes through our node marketplace / package manager, and make it so the extensibility of the program, because it's written itself in its own engine, makes it so it kind of filled up, basically opens up all possibilities so that we aren't doing anything special as authors of the application, because other authors can do the same things that we're doing for extensibility. Maybe they want to turn it into a CAD application. Maybe they want to turn it into a digital audio workstation. They could create a suite of nodes and a suite of tools that are published as nodes and put those into a big family and distribute that as a package. And that gives like whole new entire workflows or entire capabilities to the software that could be distributed commercially by someone who wants to specifically sell some package for 3D CAD or for, you know, whatever like that, because the engine is just general enough to support anything like that. Or it's, you know, some open source other like entire other project that might be just focused on building this particular workflow for digital audio workstations or something like that.
Okay. So if people want to support the project or they want to get involved, where can they go? So where can...
Yeah, so definitely go to the website.
Yeah, thank
at the
you.
moment, it's graphite.rs. RS for Rust. That's the file format for Rust. But yeah, we're looking into maybe changing the domain someday. So if that'll always be, you can always go to that domain and it'll bring you there. But we're hoping someday to get graphite.org, but it's owned by another organization that may or may not eventually be willing to give it to us or sell it to us or something. But we'd love your money to make that kind of thing and other things possible as well. So, we really are trying to make this the next Blender, the next Godot, the next Firefox, all the really successful open source projects, basically. We want to make it live amongst those as really competent alternatives that make open source not just the viable fallback, but the viable go-to. And yeah.
And if you want to learn about new features, you can look at the demo artworks. That's usually a good place to start, to look at try to understand how they are built. We do have blog posts which are always good to read. We had an update video about new Graphite features we integrated in the last months. And if you want to get involved, you can always join the Discord and just hit us up. I'm at Traductor at Kievan. And yeah, we'd love you to get involved. If you have a feature you want to work on, if you have a node that you think would fit well into Graphite, just let us know, make a PR.
And especially for existing senior level engineers, people who have existing programming experience and are good at collaborative working with the team, we have specific need for people to take over new systems that we have thus far not really focused on, because we just don't have the time to focus on specific systems, like the user experience of editing the node graph so that all the nodes just magically do what you'd expect them to do, like update their positions and update the way that you drag wires around and render thumbnails and all that kind of stuff. So that's a system we'd love to have a new owner for. We would like to have someone take over all the graphics algorithms that can be used to modify geometry, like computational geometry kind of algorithms, so you could apply a warping effect to different graphics. Anyone who's really a hardcore graphics engineer to work on different photo processing algorithms or do research into exploring how existing techniques are done for image operations. There's also the entire language side of things. We didn't touch too much on that, but it's essentially Graphene is its own programming language that can transpile into Rust. And we want someone to work on type system theory and get really advanced with that, and how we can start tracking how perhaps different values can change in their possible ranges, so we can track what's the minimum and maximum possible value in this range. Basically a lot of type system theory that gets really advanced. We need owners for that who can handle those kinds of problems for us. All the tooling, all the different rendering parts. There's basically no limit to the number of people who can take ownership of systems and really get involved with the team. We were having Teeman here. He joined 3 months ago, and he's already become a core team member because he was just quite good at what he does and managed to really take over a whole new ownership of a new system, which is building a desktop app. So it really is something we make really viable for people to get involved. We make it quite easy to follow our documentation, get working on things. And especially if you have existing experience as sort of a mid-level or senior level engineer, you can really quickly integrate with our team and become a core team member within a few months, as we've had with Teeman.
Okay. Yeah, is there anything else you would like to direct people to? Any other links to mention?
Mostly just the Discord. Join the community. We would love to have more users helping other users. I would say at the moment our Discord has been kind of developer focused. We've used it, of course, for development, but we would like to have more actual users using it on a regular basis and helping other users answer questions, show how nodes work, be a learning resource for one another, and kind of hopefully have the channels involved in general user discussion be far more active than just the development channels. And that way we can continue to grow the project as a result and have a more, just a more accessible community that we as developers don't have to take time to answer questions for users because we have enough users doing that for us.
And as a last thing, create art and
show it to us.
Share it. Show it to us. We love seeing what you guys create with Graphite. And you can also share it with others and let them know that Graphite exists.
Yeah.
Because Brody didn't know. So do your part.
Yeah, share it with your other, other YouTube channels that you follow, that kind of thing. Make it so that we don't fall under the radar of most people these days, because we really have been flying under the radar, I would say, and it's good and it's bad, but ultimately there will be a point at which people really, really start being aware of it, and I think we're probably about ready now to make that yeah. As we're about to transition in from alpha into beta, I think our goal is in the next few months to switch over from alpha to beta, which basically means we're no longer experimental so much as we are simply early on, but
We'll see
moving
about the
towards
exact dates because
exactly.
yeah, it's a Rust project. We're delayed, but yeah, we'll
Yeah.
see.
But yeah, please do take a look at the website, take a look at the different social media channels that we run, and definitely get involved in the community, either as a user or as a contributor or anything in between.
If you are not a programmer and you are the kind of person who wants to start a YouTube channel and you want to make a video on every single possible feature that Graphite has,
Yes,
that would be awesome.
Graphite has
Make the tutorial
Graphite
channel.
has in its
Yes,
Yes.
that would
in its limited times when our project has ever made it onto YouTube, there's been 3 or 4 videos. Every single one of those has very largely overperformed in the YouTube algorithm. So there is actually quite a lot of room to to be seen.
And we don't have the time to do that ourselves, so that would be great. Ideally in coordination with us, so we can let them know what things are. But yeah, that generally coverage helps.
Yeah.
And if you want to do that, that would be great.
Or if you're a video producer and you want to actually get involved with our team, or you do kind of some sort of like social media things or content management, that kind of stuff, and actually get involved, taking over from what takes a lot of time from me out of design and out of programming and out of management, is I got to spend a lot of time writing blog posts or writing videos and editing videos, that kind of thing. Because either we have nothing, which has been the problem thus far, or I occasionally, like as of recently, be sure to watch our September update video. It goes into a lot of detail. Be sure to watch that. It's actually really good. But yeah, that kind of thing, it took a week of my time, and I could have also made a mid-size feature in that same amount of time. So if we could have someone joining our team to help produce videos, that would be a really, really awesome way to help if you're experienced. I should be clear that we're not really looking for someone who's just barely beginning to get into this kind of thing. We're looking for existing experienced professionals in that kind of area, but it's a great way to kind of, get involved and help the open source creative ecosystem really thrive and grow.
Awesome. I am very happy we did this. This was a really fun episode. I am, as I said, I'm very excited for where this project goes. I wish you both and everyone else on the team the best of luck. You're, as I said, very clearly very inspired here and have a lot of big ideas, and I hope they go well. And I'm excited for the stable document format, and I'm excited for the desktop applications. Those two things are really big for me, and I could legitimately see myself in the current state it's in just swapping to it for my main production stuff. So
yeah, definitely for graphic design. And then I think in the next year, especially, that's when we're going to begin with raster, actual photo editing, something that will eventually be of the style of workflows you might use for Photoshop these days.
I guess last disclaimer, raster editing has been a bit neglected, but we are working on fixing that and making it more useful.
There's a bunch of technology that has to be built so that it can run with holding, the pixels require a lot of data, and that data needs to live in the correct location, whether that's CPU memory or GPU memory, and getting that all to be managed correctly and run in on the right compute devices at the right time and in the right state. That is all complex, and it's been a big part of the graphene development, but that's heading forward. We're getting close to that being no longer a blocker, and we do intend to then go full speed ahead next year on just raster as being kind of one of the major focuses, as well as animation. That's going to be another big focus. We'll eventually have character animation with like skeleton deformation and all that kind of stuff.
We can do another one of these at some point in the future. We don't have to keep I would love to have you guys back on, a year from now, see where the project's at, and if you wanna do this as like a every so often, like I'd be more than happy to do so. I'm very excited about this project.
Looking back a year, and then looking back a year previous, like I was physically here 2 years ago, and so much has changed in these 2 years. Like a year ago and then the year prior, it was like exponentially going from just like a toy that seemed kind of quaint and interesting and unique to now, like maybe if you ran across this a couple years ago and you tried it out briefly, you're like, oh, I can't do anything without it just crashing or the performance being terrible. Try it again now, because it's actually in quite a good state, I would say, for its intended use case of vector editing. as long as you're not importing big images or that kind of.
On desktop, that works.
It works. Yeah, we can import big images, and it almost is good performance these days.
Yeah, but on desktop, everything on desktop in Linux, and that's great. But yeah, definitely. And we'll let you know once we have the desktop app out and you can try it.
Yeah, we're also hoping to get to a recurring donations of $1,000 a year. $1,000 a month by the end of this year. So in the next 2 months, that will be our goal, to really keep pushing the growth targets there higher. So I'm not just losing money every day would be nice. So anyone watching this who really wants to have the open source ecosystem move forward with its graphics and not just be an alternative, but a proper destination, that would be a great way to help make that happen. So thank you.
Awesome.
All right.
Just one last time. Nothing else. No other links you want to mention? We talked about the Discord. Talked about donation.
Graphite.rs/donate.
Awesome. Okay. My main channel is Brody Robertson. I do Linux videos there 6-ish days a week. I haven't got a Graphite video in the pipeline yet, but I should add it into the list. Because I was playing around with it when you were talking about some of the features before, and like I haven't used it before, and it kind of just made sense. So I guess that, like, I literally haven't read any of the documentation or played around with it before, and it just clicked. So I guess, like, that's what you've done something well there.
UI design is my passion.
Not as the meme answer this time. I have the gaming channel. I stream there twice a week. Right now I'm playing through Yakuza 6 and also Silksong. If you're watching the video version of this, you find the audio version on basically every podcast platform. It is Tech Over Tea. If you are wanting to find the video, it is on YouTube, Tech Over Tea once again. I actually don't have any tea here. I have a bottle of water. No, I don't even have my cup here. Anyway, I'll give you guys the final word. What do you want to say? How do you want to sign us off?
Have fun, create art.
Make awesome things. Be creative.
Awesome.